Hi, is this an A? What about this? Is this a B? How about this? Is this a C?
That's awesome. Hey, Sean, how you doing?
Great. How are you, Tyler?
I'm great. And good morning, good afternoon, and good evening to everybody who is joining us for this webinar today. I'm Tyler, and that's Sean, and he is a leader in our consulting organization at Akka. And Sean, it looks like you're doing some sign language there. Is that the case?
Yes, that's correct.
Yeah. And I see that we're getting some responses on this interaction. And is you're capturing the video on your screen in real time?
Yes, that's correct.
It looks like it stopped on you here.
Yeah.
But you're capturing some video, and was that sending it to some sort of service? I guess something that was running by Akka?
Yes, that's correct. Yeah, we built the agentic service that pumps to Gemini.
And so, what were you sending to Gemini? Were you sending video or were you
Yeah,
sending audio to them?
audio and video, and we were augmenting with a prompt. So
Okay, so you were out prompt, you were asking it some questions, and it looks like Gemini gave you some, issues on back. But you had to send this over to Gemini, and it was sending a response. What were you doing with the response on it?
yeah, we were capturing that inside of Akka.
All right, and so you were persisting this in some sort of durable store as well.
That's correct. Yes.
Yeah,
And
and were you then like taking that response and augmenting it to the stream and sending it back to Google on each and every loop that was there?
that's correct. Yep,
Yeah,
that's
and was somehow Gemini getting smarter about your particular hand signals and what was going on?
yes, that's correct.
Oh, that's awesome. I know that we did this work for a large system integrator, and they had come to us because they had been trying to make this work for a number of months, and they were really struggling with some aspects of that. How long did it take you and the team to pull that together?
Yeah, I mean, it took us a couple of days, but honestly, we could have done it in one. We had to build the connector to Gemini. They didn't provide an asynchronous connector for us. So
You needed an asynchronous connector because the results were also streaming back.
yes, it's a bi-directional streaming. So
All right. Well, that's awesome. Sorry about the little, the blip on the exception. That tends to be the demo gods whenever you do a webinar like this. But Sean, thanks for being here, and pretty awesome to see that.
yeah, thank you.
Yeah, great, great. Nice job, Sean. Thanks, Tyler. So my name's Darren Bardick. Good morning, good afternoon, good evening, everyone. So let's go ahead and get into the material. We're going to have a really good discussion today about a pretty hot topic. I think we've got some in the neighborhood of a couple hundred people on this call today. So obviously there's a lot of people interested in the discussion. Um, we're going to get into the agenda, and we're going to actually come back to the demo a little bit, but let's actually start with a question for all of you, just so that we understand where everyone is in their agentic journey. So simple question here, if everybody can respond to this. Are you in production with an agentic services, or are you in production with another AI system, just doing project, or you're still in development, research and experimentation phase, or you're really just kind of curious and no plans yet? Or maybe you're just in the wrong webinar, who knows? But where are you on your journey as far as agentic? Okay, so while we wait for those results, we'll tee those up when they're done, and let's get into the agenda. So we have a couple speakers today. Tyler Jewell, our CEO from Akka, he's a longtime leader and product manager and executive and investor in the dev tool space. So welcome to the show today, Tyler. And also Richard Li, he has joined us for this call. He's not with Akka, but he's actually spent a long time working in the AI space. He's built out real live in production applications and services for a variety of different use cases. And he's an entrepreneur trying to do some exciting things. So thank you for joining us, Richard. As you can see from the agenda, we're going to talk about the real opportunity and some of the challenges. And we're going to get into, ultimately, Tyler's going to get into a blueprint for agentic services. And then I think what's really important is to understand that agentic for many of us is new. but actual agentic applications, agentic services, the way they behave, they've been around for quite a while. And that's, I think, an important discussion to understand how people are being very successful with their agentic projects already. And then we'll get to a live Q&A. So let's share the results, and then we'll jump into the content, and I'll turn it over to Richard. Okay, good. So yeah, looks like a lot of people are in the research and experimentation phase. And obviously a lot of people still just curious. This is obviously very new. You know, it's interesting. I saw that the search term agentic AI has increased in Google searches by 15,000% in the last few months. So obviously this is a hot topic. A lot of people are early to it, but I think this will actually be really good timing. The material that Tyler and Richard will go through, I think it'll be really good so that you can avoid some of the mistakes that are happening with people that are maybe a little further along, like some of the other people on the call. Okay, so let's go ahead and I'll turn it over, and let's have a good conversation.
Thanks, Darren. So we know that AI is transforming our lives. We're now very familiar with AI assistants like Siri or ChatGPT. And I think the hallmark of these assistants is that they understand natural language, they've got a conversational interface, and they complete tasks on demand. And what we're seeing is that these AI assistants are starting to evolve into AI agents. They're not just completing tasks on demand, they're actually fulfilling these goals autonomously, and they fulfill these goals by interacting with other systems and agents, right? So instead of a travel assistant that might say, here are 3 flight options, a travel agent might actually book one of those 3 flight options based on what they know about my preferences or your preferences. And so that's actually, I think, what we're starting to see as these assistants evolve into agents. And these agents aren't really a new concept, right? 15 years ago, we had robotic process automation, right? These are very low agency systems. They're very static. They require a lot of supervision, very task oriented. And what AI has done is it's unlocked the evolution of RPA, robotic process automation, these systems very, very quickly, right? As Darren just said, there's been skyrocketing interest, but literally in the last year, we've suddenly eliminated, or RPA is sort of very legacy, and these agentic systems, which are adaptive, they're much more autonomous, much more goal oriented, are starting to emerge and add tremendous value and productivity to how we think about agents and automation.
You know, what's exciting is that most of the assistants and agentic systems that have been delivered so far have been systems that have been standalone. And the real interesting transformation that's about to unlock over the next number of years is what happens when your SaaS applications are integrated with your agentic AI services. And you know, Gartner calls this an app/AI ecosystem. But when those two systems come together, you really end up with 3 potential values. You can get incredible personalization for your users through the condensing and consolidation of a variety of different sensors and awareness information available to them. They will automate routine tasks so that humans can focus on bigger strategic initiatives and alleviate themselves of the mundane. And these SaaS systems will be able to adapt to their environment, incorporate and solve different kinds of business needs without actually increasing in cost. And what's amazing is that, you know, it's hard to really get our arms around this, but it seems like less than 1% of SaaS systems to date have been augmented with some sort of agentic service or an AI service. And Gartner's predicting that 1/3 of all the global SaaS will be AI enabled in the next 4 years, right? So the speed at this transformation and the scale of it is quite significant. You're on mute, Darren.
Yes, I am. I'm on mute. Wonderful. So let's queue up the next polling question. To Tyler's point just there, and the interesting fact around how are you thinking about your agentic system at this point? So are you considering standalone agentic apps, or are you already thinking about integrating them in with your SaaS applications? as Gartner points out, the integration is going to just skyrocket over the next couple of years, and that is where it introduces a lot of new challenges. So building standalone, adopting SaaS agents that actually have the capabilities like Workday or Salesforce, or you're actually thinking about how to integrate these systems into an ecosystem right from the get-go. Okay, let's go ahead and share those results, Helena. I bet there's going to be a lot of not sure yets. Yeah, that's what I figured. So this makes sense. So that's really positive to see that so many people are thinking about integrating it from the get-go. About a third of people. So this is really good. So I think the rest of the conversation, let's go ahead and get to it, because I think it'll really help you think about how to build these systems together.
So it's really was stunning to me, and I think that this is when I started to take agentic services pretty seriously, was when it was framed as agentic is going to be the fifth wave of compute. In the mobile era, which is what we are in now, every user is a interactor with a variety of these systems, but we're also augmented by many connected devices, IoT devices that are out there. So there are tens of billions of users when you combine humans along with devices that are currently interacting with our systems. And a lot of large scale systems would be in the 10,000 transaction per second range. Obviously, there were systems that had to go much higher than that and systems that went a lot less than that. But because of the occasional interactive nature of how we've set up our devices and humans, that was the approximate range that we had to design and do capacity planning for. But in the era of agentic services, we still have everybody interacting and getting AI augmentation, but there are going to be potentially dozens of assistants that are aiding each of us on a continuous nonstop basis. And so suddenly the transactions per second scale could or move up 2 orders of magnitude. We could be looking at 1 million TPS as becoming the standard and norm.
So we all know that an agentic AI system is different from your SaaS application. But what really is the difference? And the best way I can think of to actually articulate that difference is that a traditional SaaS application is very transaction-centered, while an agentic AI application is conversation-centered. And this is the fundamental shift. So in a SaaS application, you have your business logic, it's stateless, and your business logic is just executing a lot of CRUD operations pretty quickly against a relational database. So that's your pretty standard SaaS application. Agentic services have actually existed for quite some time, and they were actually architected in response to some of the limitations of this CRUD architecture, right? And so a agentic service consists of an orchestrated workflow of tasks, right? And you actually put that state with the service as opposed to storing in the database. And then you choose that from a persistence standpoint, you're actually storing each event. So that way you can actually understand sort of how the service got to the state it actually is in. And then AI actually builds on this concept of an agentic service and actually layers in a large language model, right? You're sending a conversation over from your business logic and your service to a large language model, and then it responds. And the really important thing that I think people understand intellectually, but you really have to appreciate, this has all sorts of implications for your architecture and how you design your system, is that large language models are stateless. They do not remember your prior conversation. So if you ask a large language model, I would like to cancel my flight, and then it will give you an intelligent response. And then it might say, oh, is this flight 455? If you then ask the large language model, yes, that is. If you do not send over that previous conversational history, the large language model will have no idea what you're talking about and will respond with gibberish. And so what's really important as you're architecting the systems is you need to be able to have a conversational memory, right, where you typically get it from an event store, and you replay and send all that conversation over to the large language model so it has that conversational context to be able to give you an intelligent response.
Hey, Richard, can I interrupt just for a second? There's
Sure.
a question related to, go back to that last slide. I think this is just an important point on here. Will agentic AI services replace SaaS in the future? What's
I
the
think that
thought on
remains
that?
to be seen. It's a great question, right? I think Tyler has talked about how we see a world where agentic AI services will augment SaaS applications. But as we're going to talk about a little bit later, we're also going to start seeing how the interfaces to SaaS applications are really increasingly going to be multimodal. You're going to do a lot more audio visual interaction with these SaaS applications. Um, so I think in certain situations, you're going to start seeing these services, SaaS application, maybe be 70% or 80% agentic. I don't think it's ever going to be 100%, but I think depending on the application, you may see the ratio of agentic AI services to classic SaaS application functionality vary, right? And so the travel agent is sort of my sort of canonical example here. Today, you might use Kayak to search for flights. Tomorrow, you may actually just call a phone number and just book it while you're driving, right? And so those are two very different modes of interaction. Um,
And
and that may
you
be
know,
the next generation travel site.
and I'll even hop in here in that one of the things you're going to see is that agentic services really are an orchestrated loop. That loop has a pretty high latency associated with it. And so your SaaS applications are still going to have a API multi-user concurrency interface to the outside world. And it's going to have to handle a volume of traffic that is near real time. And so the agentic loop is not really well suited to that high volume of end user concurrency. And so really what you're going to look at is you're still going to need your SaaS layer as we've known it for that level of user interactivity, augmented with the agentic loop that is providing the knowledge and intelligence working together.
Yeah, I think based on some feedback that we're seeing in the chat, that definitely people are agreeing that it can't be 100% for the fundamental reason, not all cases are stochastic outcomes. So, and there's some other people chiming in here, so that's good. Okay, moving on.
Yeah, so when I talk about orchestration, I really mean workflows, right? So workflow is just a graph of tasks, and you can create graphs in any sort of shape and sizes, right? So it can be sequential, it can be parallel, event-driven, et cetera, right? And so again, if I use the travel agent, you might have a parallel workflow. You might search for flights and hotels to make sure those are both available for the dates that you want before you actually build your itinerary. And then the powerful thing, as you start sort of building this agentic infrastructure, is that some of your tasks might actually become more complex, like a flight search. You're not just looking at one website, you're looking at 20 different airlines, and you might be looking at availability of business class seats or first class seats or aisle seats or whatever. And what you can do is you can actually start to delegate that to a subtask agent where you create a flight search agent. And so you can start orchestrating and chaining these complex workflows and decomposing specific tasks to specific agents. And so that's actually how you start building this pretty powerful agentic architecture.
Yeah, and
sorry, and then sorry, there was a little lag in the slides transition for me. So so when you start thinking about the different workflows that actually exist, when you actually start creating the more sophisticated workflows, you start creating higher levels of agency. And one of the keys to creating very high levels of agency is this augmentation loop. So what you can do, right, I'll take this left-hand example, the retrieve augment loop, right? You can retrieve some knowledge. You send that with a prompt over to your large language model. You get a response back. And then what you can do is instead of just sending that to the user, you can actually add more context, more business logic to it, and then ask the large language model to process that context all over again. So all the previous conversation plus any new information. And this is one of the most powerful ways to improve the reasoning and quality capabilities of a large language model. And this is how you actually start to increase agency in your system. The other thing is conversations are stateful, right? So again, I talked about how our large language model has no memory, right? So a conversation, it's this ongoing conversation, right? I want a refund for my flight. Did you mean this flight? You get a response. Yes, I need to cancel. And so you need a conversation journal where you're appending every single part of that conversation to this journal, right? So that you can send it over as part of that session to a large language model. And then after that, you also need to be able to make sure that journal is persisted both in memory, because you want to be able to do real-time business logic and computation on it. But it also needs to be durable, because if there's a network failure or there's a hardware failure, you need your agent to be able to resume that conversation with the LLM before, without forgetting everything that happened. So those are some of the things that you need to start thinking about as your conversations are very stateful. I talked about the AI augmentation cycle, this loop, but there's one nuance to this loop, right? So you add new context, you query your large language model, you append your response, and you add that entire conversation, the context and the response, to your conversation journal. And you repeat this over and over again. And you can improve the quality of the response from the LLM as it goes through this conversation. But the challenge is the conversational journal gets bigger. It keeps on getting bigger. And eventually you're going to hit the maximum token capacity of your LLM in the extreme case. So it's really important, as you're sort of architecting your system, to think about how are you going to manage the size of this conversation journal? How are you going to manage the capacity of your LLM? Because fundamentally, the power of your agentic system is constrained by your LLM. So you're going to need a lot of smart strategies around how you actually send tokens and context to your LLM without overwhelming it and causing it to crash and be useless for everyone.
And on top of that, as you saw at the beginning of the session, it's not just conversational chat, which is the modality of an input into an agentic service. You're actually going to have a lot of IoT and edge devices that are going to act as sensors for their environment. And when they're sensors for their environment, they are going to be collecting these metrics and streaming them in on some sort of continuous basis. That's generally what's considered real time. And then the same thing for audio and video. A lot of agentic systems are going to be able to capture the human voice interaction or talking to the application, or even watching how you are working and then being able to act on top of that. The challenge here is that you then have to be able to ingest all this information at real-time speeds, augment it at the speed of the ingest, and then forward it on to the appropriate LLM or other models in a way that doesn't overwhelm the LLMs or overwhelm the agentic services that are processing all this sort of data. And as you're going to see, these LLMs are significantly slower with a much lower overall capacity and a higher cost. And so this balance between what the agentic system is processing in real time and what the LLM can handle is a delicate balancing act.
Hey, Tyler, could I interject there? And I think it's a good tee up for the next slide as well, but go ahead and cue up the next slide. But one of the questions is, why wouldn't I just ensemble a set of small language models together instead of just overcoming LLM limitations in this fashion? Like, why wouldn't I do that?
So I think if that is in relation to the streaming slide, I mean, the issue there is that the LLMs by definition generally don't accept streaming inputs, right? So there's still a stateless nature. So you're still going to need to have an agentic layer that is able to process all the streams and then augment that stream. So you have to take the raw data and do the knowledge retrieval and the augmentation prior to forwarding it along. The choice of whether you have one LLM or many LLMs is really going to come down to a couple of criteria. One, the performance of that LLM. Different LLMs have different performance profiles, which also then dictates the type of latency that you're going to get out of those LLMs, which also dictates accuracy and cost. And then also you have LLMs that are well suited to certain types of modalities. Some are intended for images, others are intended for video. And so you're going to have to be choosing between that. And when you get into a proper agentic platform, and as you'll see, including with Akka, the agentic tier will have performance, functionality, and cost variables that the agent can factor in choosing which LLM that it wants to forward the messages onto.
Great. Thanks, Tyler.
So hopefully at this point, Tyler and I have convinced you and explained sort of that an agentic AI application is very different from a CRUD application, right? And so we're all very familiar with the N-tier application architecture, which has been the de facto standard for CRUD apps, right? You've got a web tier, you've got an API tier, we have your business logic, and your business logic is sending thousands of transactions per second to a relational database, which is actually very low latency. 10, 20, 30 millisecond P99 latency. The difference is with an agentic AI application, you're using large language models, and large language models have latencies that are a couple orders of magnitude greater than a relational database. To the earlier question around using an ensemble of small large language models, you absolutely can do that, and that might reduce your latency a little bit. But at the end of the day, you're never going to approach the latency of a relational database, particularly as your conversation history grows, right? So you have a large language model or set of large language models with 100x the latency of your relational database. You may have a vector database for storing some semantic data that you want to also retrieve. And again, a vector database is faster than a large language model, but it's certainly a lot slower from a latency perspective than a relational database. And then you have your event database. And so you really need an architecture that takes into account the very, very high latency of these critical systems, your LLMs and your vector databases, that you really don't have in your CRUD application. And then on top of that, we just talked about how you need to think about orchestration, right? So you have, some of these agents may run not just for seconds, right? But they might run for hours or days. So you need to start thinking about orchestration, the conversational database to actually augment that context. And then finally, as Tyler mentioned, has been talking about, you're scaling this, the transaction volume and calls from, millions of transactions per second to trillions of transactions per second. So thinking about how you actually elastically deploy your agents in a way that maximizes utilization of the compute that you have is also critical. So you really need a pretty different architecture relative to, your traditional CRUD application.
And let's start talking about some of the capacity planning implications of that. And when I first started seeing some of these numbers, I thought they were hyperbole or potential exaggerations or even jokes. But the reality here is that there are going to be more users with more transactions, and those transactions are each going to be slower and less predictable and more costly. And we did a comparison. We took some large database only environments that were purely transactional built with Akka, and we looked at the cost per transaction for a single database call, doing a write versus a single LLM call. And when you looked at that, the cost increase for a single call was 10 to 10,000x. And that was kind of being generous, because if you take the world's most accurate and sophisticated open source LLM and look at what it costs to do 1 million tokens, that is roughly 850,000 times more expensive than a single database call. And that's just kind of ridiculous where it is right now. Now, the good news here is that since LLMs were introduced 3 years ago, each year the cost per LLM to maintain the same accuracy has come down 90%. It's been very consistent each of those 3 years. So, can we use that as a predictable measure that it's going to continue to come down? I don't know if it will come down at the same rate, but there is going to be a lot more cost-efficient LLMs that get introduced into the market, and we're going to have to embrace that and be ready to adapt to a lot of new LLMs very quickly, because really one of the most critical design criteria for any sort of SaaS plus agentic system is going to be an efficiency criteria. I mean, it's really cost and efficiency and performance is going to be the overarching criteria for a production system. And, and it's no surprise that Gartner did a survey. It was well over 1,000 organizations that responded, and they said 48% of those organizations were able to get their agentic system into production. 52% failed. Now, they failed for a variety of reasons. Some of those reasons was that it was experimentation. Some of the reasons were that they had data quality issues. There were a lot of organizations that were concerned about security and data privacy, but a big portion of those applications were just not industrialized. They were not ready for the load capacity. They couldn't get the cost equation on the LLMs to work right. And a lot of the agentic services that they had been using were in Python or related technologies that were not well suited for concurrency, memory management, or things that you're going to be running on a 24/7 basis. So it's no wonder that there have been some issues with getting into production. And on top of that, because there's so many different moving parts, a lot of these organizations have been taking well over 8 months to get that POC into production. And so that leads us to our last polling question, Darren.
Yeah, good. So I'm glad you brought up the cost conversation, because there's been a couple questions about that, because it sounds like it could get very astronomical at this level of scale, and how these agents never sleep. So let's queue up the polling question. So there were about 75% of people that responded that they're not in production yet. They're not even developing something. They're researching, they're experimenting. But as you think about how you're going to deploy, are you thinking about pure cloud native agentic platforms? Are you thinking about your virtual private cloud, or self-hosted, where you're pretty much running on Kubernetes and you kind of set it up your own? You kind of rolled your own environment in order to do that. I think an important point is this is a multiple choice, right? You can choose all three, depending on what you're thinking. And it's funny because one of our a gentleman that Tyler and I have both worked with in the past, John Whitaker, he works at EY and he's been in the AI space for a while. He made the point in the chat that many people are thinking about all the different models in terms of standalone, integrated with SaaS applications, and there's really becoming almost a mesh of these applications. And I think that's a great point, and it can be also applicable to these deployment models. So let's see what the results are, and I'll share that with the group, and then we'll move on. Okay, interesting.
Wow.
So it's almost about a third. So deploying strictly in the cloud, about 62%, and only about a third are saying a virtual private cloud, and then about half are saying that they would roll their own and have a self-hosted environment. So really a good mix. So obviously that's people thinking about multiple different deployment models, which is interesting. Okay, great.
All right, well, now it's time to get into, what is our blueprint for agentic services. And, we've spent a lot of time, you're going to see some examples of projects that we've been working on over the past many years. And we have come to this very simple understanding that an agentic service and an agentic service platform has 5 elements to it, 5 really important parts. The first is that you need to be able to do streaming endpoints. You got to be multimodal. You got to be able to handle real-time data. And you got to be able to then stream that information from the endpoint to the second thing that you need, which is agent connectivity adapters. So you got to be able to integrate with vector databases for semantic search. You need to be able to integrate with all kinds of different LLMs, and along with other database systems and third-party systems, because you are going to be doing integration, and these LLMs are going to be able to eventually take action on your behalf as well. So you're going to have a set of these capabilities within your environment. And then obviously the heart of an entire agentic system is that you got to do agent orchestration. So you have to have a workflow engine that supports all those different types of models, whether it was parallel processing, human in the loop, state machines, event driven. And since augmentation is going to be a fundamental part of your loop, you need to have a context database. And you don't want this context database to be outside the agentic platform. It needs to be inside of it. It needs to be in memory and durable, because it will become quickly a bottleneck to the system if it's not there and part of your augmentation loop. And then because you're going to have so many of these agents, you're going to have some mechanism of governance around all those agents. So therefore, that's lifecycle management. And of course, this entire system has to be secure, scalable, and observable, because it's not a platform if it isn't. And so this is a standard. This is what you should be looking for as you go to choose your agentic platform. And of course, this wouldn't be an Akka webinar without saying that, hey, Akka is a platform and we are a vendor that is going to be in this. We are in this space. We're going to be much more competitive in this space. And we look at Akka as providing a bunch of really special capabilities here. Not only is it an agentic services platform, but it's also a platform for your API services and your data services so that they can coexist with each other. You can use Akka, and of course, we do provide a variety of endpoints that you can build, but they're custom endpoints. You can design them however you want to see fit, but they also support all these different media protocols. They are multimodal by definition. That demo that you saw at the beginning, we were doing a gRPC endpoint with streaming video live from Sean's. It was actually on his desktop that was streaming in. In addition to this, we now have a variety of agent connectivity and adapters. We have a host of ML adapters that have been built and a bunch of LLM adapters that have been built. And what is very important about this is that we look at LLMs as event-driven machines. Generally, most AI inference systems look at it on a batch basis. They open the connection. It's a long-lived connection. And when the LLM responds, as you've seen, like when you use ChatGPT, it kind of streams its response. So it's chunking that response. Most AI inference systems treat that as a blocking exercise. And so you wait to batch up the response before you can act on that. And with our adapters, we have turned them into non-blocking adapters with back pressure, but more importantly, we can stream the events from the LLMs back into the system for reasoning or all the way back out to the endpoint for streaming out to a browser. And when you do all this, one of the powerful elements about what makes our system unique is that your API services and your agentic services are running on shared compute. And when they're running on shared compute, you avoid the island problem. And that's where a lot of the efficiency comes in, not just in lower compute for all your services, because we can balance all the transactions automatically, but we're actually a lot more efficient in the invocations to the LLMs. And so you get a higher yield and higher efficiency on these expensive and slow latency LLMs as well. And with that, our focus is going to be on the accelerating the delivery of agentic AI apps. And this is just coming back to that, what happens when your SaaS applications, which are going to have these varied multimodal experiences coming in for their users, and you have to integrate those with your agentic AI services. And so this is the industrialization process. This is that time where agentic AI is starting to graduate out of data science and data engineering into R&D and fundamental delivery organizations. And so with Akka, we're going to have a common SDK, shared compute for for both your applications and the agentic AI services, and that's how you get the personalization, the automation, and the adaptation. And I just want to underscore here, beware the workflow island and what that's going to do from productivity and a cost point of view, and also beware the framework trap. There are a couple of frameworks out there that are wildly popular that make it really simple to get started, but then you run into production-related issues of locking concurrency and memory that probably not well suited for 24/7 operation.
Hey, Tyler, let me interject here for just a second. There's a lot of questions coming in on the chat, which is great. Keep them coming in. Let me just interject with one. I think the question is, let me just read it to you, Tyler. So really like the thoughtful and intentional design approach here. Do you think of this as a stack or as an ecosystem? Is this more about infrastructure or is it a platform? Like, how do you think about approaching this? How are we looking at it?
Yeah, I think the way Akka, the company, is looking at this is we are seeing the emergence of a new stack. And I like the way that Richard framed it, which was we're seeing the evolution from N-tier architecture to A-tier architecture, which is something that we've coined. And the agentic tier architecture is really not a displacement of your SaaS architecture. It's an augmentation of that. It's your SaaS architecture with the combination of your semantic search, your LLM, and the inference and the context database. And so, and because your agentic services are going to run independent of your LLMs, this agentic services platform becomes a fundamental part of your SaaS infrastructure with that. So we're looking at this as an emergence and a shift in the stack structure.
That's great. Great. Thanks for that.
This is obviously a huge eye chart, but this is a list, and we'll give this to everybody who's on the webinar, but this is everything that we have been engineering for the past couple of years, which is agentic and AI specific. And these are all capabilities that are part of Akka today. And we can educate you on the things that we've built here and how we've done that and how you can make use of that. But a couple of things that I really want to point out as really critical that we think is an important part of our particular implementation. One, the LLM adapters and treating them as non-blocking, asynchronous, event-driven machines. That's pretty fundamental, because in order to get the efficiencies, everything needs to be non-blocking. Everything on the outside, everything on the inside, and that's really where the strong efficiency comes to play. The second part is that context databases are just automatic, and they are in memory and durable. So they are part of the services that you run. It's not that you have to stand it up separately and differently. I think that's a pretty big part of that. Our event-driven system has been benchmarked to 10 million TPS, and we're going to talk about one customer who is over 3 million TPS with an agentic service they've used with us. So we can get to the levels of performance that you need to get to. And also, we do have a workflow component for developers. You actually build workflows with all the different models that are there. It's easy, it's expressive, it's simple to get started with. Most developers can start programming these things in under a day. The training is pretty straightforward with that. And the last thing I'll say is most people aren't really aware of this, but we are actually a multi-region solution. And so you can run your agents in multiple different regions, and we'll do live replication of all the context data between that. And we apply replication filters. So, and what that allows you to do is you can have some users with GDPR or other compliance regulations operating in one region, other users operating in a different region, and then you replicate the relevant pieces between the different environments in a fully automated fashion. Akka, more than 2 billion people on the planet touch an application that is powered by Akka on a daily basis. Most people have no idea that that's the case. You can go to our website. We have a repository of more than 40 really interesting case studies. And at this point in time, when we think about our customer base, we've got 40 or 50 known customers that have agentic services in production today, and about a dozen of those are AI specific. With agentic being the orchestrated and stateful behavior, AI being the use of an LLM. And a couple that are really exciting to talk about. There's an open source project. It's called Smile. It's been around for 18 years. Haifeng Li is the maintainer of this project. He started on it after he got his PhD, and he has been maintaining that for almost 2 decades. It has a significant number of downloads, but Smile has support for hundreds of ML algorithms and LLMs. And it's actually used in a variety of different ways. It's inside of Amazon in a bunch of different areas. He was working on SageMaker for a while as an Amazon employee. It's powering Google Earth, and we have a close relationship with him, and it provides its own AI inference server as part of the package, and that was built with Akka. And his reason for why he needed to do it was for the very reason that we talked about. It was event-driven inference in a non-blocking asynchronous way. So Smile is powering a lot of production-grade ML systems, and that has also been built with Akka. So we're pretty proud of that. Swiggy, who just had their IPO and been an amazing success in the Asia Pacific region, and you can see a blog about them on our website. They have a variety of models that they have built over time. Those models, some of them are in Java, some of them are in Python, some of them are in Go. So they have a lot of different languages that they've implemented those models in. And they all have varying different levels of performance. And so they did a inference, basically a model inference layer implemented with Akka. And what they did is not just orchestration, but batching of a bunch of different calls in intelligent ways. And as you can see, they got their P99 latency down to 71 milliseconds. And that was like a 90% improvement prior to them implementing that inference layer. And Tubi is really exciting because in addition to them having multiple models, they also have multiple different data sources that are coming in real time. And so they get into the multimodal aspect of different data coming in so that they can do this personalization service. And we also have a couple of great startups that have leveraged Akka for inference here. Horn, we like to call out because it is a very similar to the demo that we started the call with, but they are doing this in production and real scale, augmenting basically like Zoom style conversations, but adding AI capability to that. And Coho AI, they evaluated all kinds of different agentic vendors, and they've concluded that they could get to market 75% faster. And then they did that. They got to market months before that they would have otherwise because we enabled them to get to production.
Yeah, Tyler, we've got a bunch of questions in the chat. We're about 10 minutes out. I just want to make sure we get to that. So
all right,
let's
what
wrap
we're going
up.
to do here is, so this is the case study of the demo that we started with for that large SI. This will be in your packet, and you can see how we did it and the way that we did it and what we used to build it out with. And then on top of that, what I really want to emphasize is that we have a concept to production capacity where we believe we can take any concept and get you into a production ready state in 8 weeks. We've done this before. We know how to do it. We've got a structured methodology here that takes you through the agent selection, the development of the platform, the AI model, the AI inferencing, build, test, optimize. We can get you there in 8 weeks. But we understand that that might be too much to get started with. So we also have a call out here talking about proof to value, Darren.
Yeah, so I think based on the audience, there's a lot of people still doing research and experimentation. They haven't even gone into production. So I think this is a really good start for you. So if you're interested, go ahead and scan this QR code, fill out a little form with us, and we will literally help you take it from concept to a proof, like almost a prototype that you can really see your idea in action in about 48 hours. Much like what we did with the demo that we showed earlier in the conversation today. So scan that QR code, give us as much information about your use case as you can. We don't expect everything. You probably even haven't figured out everything, right? But then let's have a short meeting and we'll get going on it, and we'll show you something. So I think it'll be, I think it's really important to acknowledge that there's so much hype going on in the AI space that let's get to really putting our brains down on paper and putting our hands on the keys and building something, and let's see if it works. You know, let's get you into production a lot faster than that 8 months that Gartner talks about. So, okay, great. Thank you, Richard. Thank you, Tyler. This has been really good. There's a lot of questions. Let's go ahead and start taking some of these questions here. I'm going to start with kind of the bottoms up here. So, how does the new I knew this would come up, and I just want to get it out of the way because there's a lot of people that have this question. How does the new Akka capabilities around AI, how does it fit into the business source license that we introduced a couple of years ago? Tyler, you want to take that one?
Yeah, so with Akka, we have multiple deployment options. We have a serverless cloud option where all your cost expenses are covered and paid for. Most of our customers are deploying a bring your own cloud model where it's deployed within your VPC, and that has a managed service fee, kind of a monthly managed service fee associated with that. In that situation, we're managing it for you, but it's in your cloud VPC environment. And then we also have a self-hosted option as well. And this is where the BSL really goes into effect. So with the self-hosted option, you can get this entire platform, you can get it installed. it is under the BSL, which means it's free for development. You need a commercial license for production, but because it's BSL, it does revert to Apache licensing after 3 years. So there is a lock-in avoidance provision there, and that you can deploy this, you can run this if you're happy with it. After 3 years, it's Apache license.
That's great. Okay, good. Yeah, and importantly, the same product that you're going to build other services with, you can build these agentic AI services. So, okay, good. Response times and latency are not important for all kinds of applications, and this would become a concern only after a certain scale. What kind of application areas are you seeing enterprises be highly concerned about latency and seeing it as a major challenge? So where does this, is this a particular use case, or is this blueprint and this format applicable to certain industries, certain size companies?
Well, I think, Richard, you should just talk a couple of minutes about your own experience with this. Yeah.
Yes. Yeah. So I actually, one of my, when I started working in AI, I just started building my own sort of AI application. And I started with an N-tier architecture because what did I know? This was 2 years ago, and I got some users, and very quickly, around 5 users. So this is not like I'm not running an airline reservation system here. I started running into a lot of these challenges around latency, right? Because even at very small scale, you experience latency. And the second thing is, yes, there are a lot of techniques you can use to improve the latency of the large language model, but they all come with various trade-offs around throughput. And so what I found is that I had to implement a lot of load management. And so it's not just about latency, although that's a big thing we've sort of talked about. It's also about managing the capacity of your large language models so that you're not overwhelming them. And so I would say, in general, if you're putting in an LLM, which is a very constrained resource, a better way to think about it is it's a high latency resource, but more generally, it's constrained. You actually have to think about how you're going to manage those constraints.
Great, great. Okay, so I want to revisit the question about multiple LLMs or using multiple SLMs, smaller language models. Richard, you want to talk a little bit about that as far as how you see that happening, and
yeah,
is just using multiple, is it just the answer?
Yeah, so there are a few questions where they talk about, people talk about prompt caching, and I know everyone on the call has probably various levels of experience with using LLMs. So one is, in general, I would agree that you will probably, if you're moving into production, use multiple different models. Some which you may self-host, some which might you use different providers for. And there are 2 reasons for this. One is cost, actually 3 reasons. One is cost efficiency, because smaller models are cheaper to run than larger models. So you don't always need a larger model. The second reason is just performance, because smaller models perform better than large models. And the third is availability, right? And so you're probably going to run multiple models. But if you think about it, what happens is, how do you decide which model to run? Well, you actually have to start putting that into your sort of agentic layer to actually do that model routing. And so, I think my larger point is, no matter what you're doing in terms of optimizing the performance in the LLM, it turns out there's actually quite a bit of sort of infrastructure logic that you will have to build into your agentic tier to sort of capitalize on all this sort of LLM optimizations that you may choose to deploy.
Yeah, good. Yeah, I think that's, I think it'd be a mistake if we try to, if people were thinking that latency was the only issue. Obviously, security, data quality, and other issues just around, if you're training your own models, this is a big space. But I think in terms of when you're really getting ready to build these systems, latency does become a problem really quickly, and because the scale and the interactions with them, it's totally different than just user to user model. So, okay, good. Cost seems to be coming up a little bit in the Q&A as well. So, and Tyler, maybe you can talk about this, but also Richard, as we think about it, is this really just the cost of infrastructure? Is it the where else does cost come into play when running these systems?
Yeah. So I think that the big cost drivers here are going to be, you're going to need to host your LLMs or the models, right? And those models have a performance footprint. Now, if you're going to use a cloud-based LLM, it's real obvious they price per million tokens. You can estimate approximately how many tokens you're going to send per call, and you can figure out the total cost right away. Those costs are already pretty steep, so a lot of enterprises are going to be hosting their own models on this. And so, you know, when you host your own model, then you're really just looking at how much compute and how much memory that are you going to need to, you know, have in order to support all of that. There is some storage dependency associated with it. Your vector database is going to be, if you're going to be doing any kind of semantic search, that is going to be a pillar of cost that is new and additive that you're going to have to consider. And then your agentic platform itself. Now, your agentic platform is roughly going to be the cost of what your SaaS platform has been, although it is going to be handling more transactions. So it's probably going to be not quite a linear expansion of that cost, but an increased expansion of that cost. And that's one of the reasons why we think Akka is well suited for this, is because there's so many high efficiencies that we will not have your agentic, if you will, the SaaS platform cost increase as much as the semantic search and LLM is going to be driver of.
Yeah, good. And then Tyler, what about the human interaction with it? You know, the teams that are running it, are these going to be harder to run than traditional SaaS systems?
I think operationally it's going to be, you know, very similar to run. There's going to be some more components that the operations team have to, you know, embrace, and they obviously have a different backup and recovery upgrade workflow associated with that. So there is some skills that they have to acquire. But, you know, really, I think the biggest challenge with a lot of these systems getting into production is not going to be the operational elements of how you manage your models and how you manage your vector database and the agentic platform. Frankly, it's going to be the explainability and traceability of the AI itself. You know, how do you know whether it's starting to hallucinate, and that the results that you're getting are starting to get out of the realm of what you were comfortable with in the testing and early use cycle. So these agents will evolve. Your LLMs will evolve. And so what's going to be that cycle for how you keep things within an acceptable set of parameters?
Yeah, good. So I think that transitions into the next question I was going to ask. Regarding lifecycle management, do you consider the evolution of the user's knowledge and understanding of the AI capabilities as part of the lifecycle? In other words, how do you account for users getting smarter?
Well, I think that users are going to interact the same way. I mean, so the functional interactions are going to be the same, but but then the results are starting to going to be different. Now, whether you bake that, do you want to bake that into the agentic loop, that the loop starts adapting to different types of end user behaviors? I think that that's more of a planning and a product management exercise for those people who are starting to think that way. But it also starts to get back into the explainability issue and the degradation of the agents over time. So there's this need of kind of keeping them current. And so you're also going to have to just keep the interaction model current as well. And that's just the nature of how these systems work. They change over time.
Yeah, good. Okay. So let's see, we've got, we're right at the top of the hour, but anyone that wants to stay on, we'll stay on for a few more minutes and tackle a few more questions. Just to reiterate, there's been a few people that have asked, yes, we will be sharing the slides. We'll be sharing the recording of the actual webinar itself, the on-demand version, and we'll share a transcript of the Q&A if that helps anyone. So here's another one. Are we also trying to build some orchestrator-like LangChain, or I think that's what they mean by it, LangChain within the Akka ecosystem, or are we saying that use the available orchestrator from the world and stream it for low latency by using Akka?
Akka's providing its own orchestration engine, and so a lot of that, all that capability is there. And what we've been working to do is that kind of workflow component has something that was emerged for us about a year ago, and now we're going to be shipping AI flavors of that workflow orchestration capability as well.
Yeah, good. I think that was one of your prior points, like just adding workflow on top of these systems, if they're not closely integrated, it could cause a problem.
And what I want to make the distinction is most workflow systems are things that you install, And then separately, you define the workflow and install the workflow into that system. The Akka model is that you develop your agentic agentic service, if you will. You code it in a very simple coding structure, that agentic loop, and you use our workflow components. So we basically give you very simple calls to make. And so you are coding that orchestration structure that you want. And then when you compile it, which by the way, you can run it locally, offline, easy to do, but we compile it and pack it into a distributed set of microservices that then run inside the agentic platform. So this isn't like a workflow engine that you install and add into. You are actually creating the agentic service, and then your agentic service is clustered, replicated, everything like that. And we automate all that as in the injection into that service for you.
Yeah, good. So next question. So do you folks see the agents querying the business database directly anytime soon? Or is it going to be through existing APIs for the most part? Where does the database come into this whole conversation?
Well, I think there's a lot of efforts underway for enabling both user data, user tooling, and enterprise system data and system APIs, and describing that all that data in a useful metadata structure, and such that metadata structure can then be discovered and acted on by your LLM. So this is very early stage. And so imagine all the third-party systems, there's going to be a mechanism by which they can expose themselves in a way to make it more understandable for your LLMs to interact with. And it's not just for knowledge retrieval on those systems, but it's also to be able to take action on that. One thing is there's this thing released by Anthropic called the Model Context Protocol, MCP server. And it's really intended for AI assistants. It's not intended yet for AI agents, but it is something that you can add into like a Claude desktop. And it basically allows you to start integrating Claude desktop with a bunch of different third parties so that you can start writing prompts like, oh, hey, I'd like to update my worker at Cloudflare. And then Claude knows how to interface with Cloudflare and update the worker on your behalf. So the MCP is, I think, a non-enterprise early variant of what's going to happen there.
Good, good. I'll ask you both to kind of chime in on this one as far as what you think about it. One of the questions is about how should they think about Akka in terms of the overall ecosystem and the stack that they're going to need to build? Do we think it's okay to think of, or should they think of Akka as almost a developer platform? Like, are they building a platform to then build on top of that and seeing multiple layers? I think it's interesting because that's how actually many customers use us. But Tyler, you want to chime in, and Richard?
Well, Richard, I apologize. I got interrupted for just a second there, so I didn't catch the whole question. I'll let Richard handle that.
Yeah, so I think you can definitely think of Akka as a developer platform. And I would for you to build your agentic services. What I would probably think about is what you will do over time is you'll probably have some additional libraries that are specific to your infrastructure. You may have that you will build on top of Akka. Like, for example, if you have a particular authentication mechanism that's custom to your organization, things like that, where Akka, it doesn't make sense for Akka to provide out of the box, I think those will become part of your developer platform. But I would say that Akka today, Akka 3, provides all the core primitives you need to build your agentic AI development platform today. And I think there was a question around comp to backstage. So I would actually defer to Tyler if there is sort of a internal developer portal with Akka. I just don't know. I don't know if there's an IDP with Akka. So.
Yeah, on the IDP, it's interesting in that we did a study. So the definition of an internal developer platform is it's not intended to be a PaaS or an orchestration system. So the IDP is not actually the runtime where you run your applications and agentic services. What defines an IDP is a couple of things, but it's usually developer kind of gold template processes that you use. It's a form of governance. It's also a form of shared metadata between those organizations. And it's also doing a lot of metrics, tracking for productivity. And generally, IDPs are designed to work across many different teams and a bunch of different runtime platforms. And in what we think of Akka as is it's not an IDP, but we are IDP compatible. Like we can, but we are a specific type of runtime for your applications. And of course, we will work with whatever IDP you want to make use of.
Yeah, I think one of the interesting things is there's so much flexibility. It really depends on what you're trying to do. Whether you're actually building out a platform to build on top of other services in your business, or you're just looking at one particular service. So, okay, so let's take one more question because we're a couple minutes past the hour. Thanks so much to everyone that are still hanging on, but we want to respect your time. So let's see. Richard, I know you've been looking at the questions too.
I'm actually just gonna hop in here, Darren, and
go for it.
Go back on here, but put that challenge back out there. We've already got 5 submissions, Darren.
Okay, this is good. I think
let's do it.
It is so exciting. The interest in the conversation around Agentic. I mean, it's hot for a reason. There's a lot of value here, but I think there's a lot of problems that we can collectively work on together and help each other avoid. So it's just a fascinating time for all of us to be in the space. So let's go ahead and wrap up because there really are a bunch of other questions. We'll go through the questions that have still been posed. We'll answer them in text, and we'll provide those as part of the transcript to the Q&A. But I just want to thank everyone for attending, for staying on past the hour. You'll be seeing a lot more information. I will point out, there's a lot of vocabulary. There's a lot of different levels of knowledge in this space. We have been very happy to share a lot of information and a lot of different levels of training on everything from the reactive architecture over the years and all the way up to how to use Akka itself. But definitely look for us. If you care to subscribe to our newsletter, just go to our site and pay attention to us on socials. But this is going to be a fun ride. Richard, thank you so much for joining us. Tyler,
thank you.
Great job as always. Thank you. Yeah, and Sean, thanks for starting us out in a pretty unique way in this conversation. Hopefully everyone enjoyed that little mix up because usually you see a demo at the end, but we mixed it up a little bit. So, All right, guys, thanks so much. Let's everyone good luck in this, and we'll be talking soon.